Hell yeah. Alright, under 2 minutes we can tackle all these. This was the diagnostic test for algebra in the calculus book James Stewart. So if I have negative 3 to the fourth, I'm going to just have this term multiplied by itself 4 times. The negative goes away. I'm going to have 3 times 3. That's 9. And then I'm going to have another 3 times 3. That's 9. And then 9 times 9 is 81. Booyah. Now this is a little bit different. I have to do that 3 to the fourth. Let me get that 81 and then just put a negative in front of it. In the length of the video, we kind of go into more detail on how to show that. Now this is 3 to the negative 4. This is the same thing as 3 to the negative 1 times 4. So, I think we all know this is just like the invert, like you invert the number, 1 divided by 3, and then take that number to the fourth. In the video, we're going to show just a lot of different ways to do that. But if you did that, we'd have 1 divided by 3 to the fourth. 3 to the fourth was 81. You're going to have 1 divided by 81. Now this is a boatload of 5s upstairs, a boatload of 5s downstairs. There's 2 more 5 times 5s upstairs. So this is going to be 5 squared. And that's how you get like, hey, 5 to the 23 minus 21. That's going to be 5 squared. Hell yeah. Now this, same thing. We can invert it and then square it, or we can square it, then invert it. So if we invert it, it's going to be 3 divided by 2. Square it, it's going to be 9 divided by 4. If we squared this first, it's going to be 4 divided by 9, and then invert it, 9 divided by 4. Hell yeah. Now this is the tricky one, because we have a negative 1 multiplied by 3 multiplied by a quarter. Now the 1/4 indicates a root. If you can get something down to 1/4, or like 1/5, or 1/2, or 1 divided by any number, that number, 1 divided by whatever that number is the number of times you need to multiply something to equal that number. So 16 to the 1/4 is the fourth root of 16, saying, hey, what number multiplied by itself 4 times is equal to 16? And that's going to be 2. 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So I can do that first, and then I get 2. Now I can invert it and then cube it, or I can cube 2 and then invert it. So let's take 2 cubed, that's going to be 8, and then invert it 1/8. Alright, hell yeah. So 2.5 minutes, not bad. And now watch the rest of the video to show just all the ins and outs of how to do these problems. Alright, hell yeah. So what we have here is 10 questions. This is a diagnostic test. This is for algebra. Now this is the intro to a calculus book. This is James Stewart, the 7th edition, 7E. I got a PDF online, so I just kind of went through these. So actually I've only done like the first 2. So everything else is going to be kind of from scratch. I don't know if I'm going to make this into a playlist or just try to tackle all 10, because in each 10 questions, there's, A through whatever. Alright, hell yeah. So we're going to evaluate each of the expressions. Alright, maybe, I just thought for all of them it says don't use calculators. I think for the most part, we're not going to use calculators. So hell yeah. So what is negative 3 to the fourth? Well, that's just going to be negative 3. And sometimes it is helpful just to do what no one's going to do. No one's going to write it out like that. It's just kind of a pain. But you can see that negative 3 times negative 3 becomes positive 9. So we get 81. 81 for that one. Alright, booyah. Moving on. So we have, what's this? Now this trips me up. Well, hey, check this out. So I've made videos before that I just absolutely hate negative signs. So what you can do, and it work. Let's go back to this problem, because this is pretty sweet. Let's say you don't even like this negative. Well, just say this negative is a negative 1 times 3. Sweet. So that's the equivalent of negative 3. And then so we're going to have negative 1 times 3. Whoops. Sorry. So negative 1 times 3. And then we're going to do this to the fourth. So, and especially with these powers, you know what I mean, it's good to do this, because you can see if we have a product of 2 numbers and we're taking it to, an exponent, then what we can do is we can bring that exponent into each of them. So this is the same thing as negative 1 to the fourth, and then times 3 to the fourth. So now we have a different way of doing it, and it kind of double checks, reality from doing it one way. So let's do this. This is just negative 1, negative 1, negative 1, negative 1. I'm going to run out of room, but we have to do 3, 3, 3, and 3. All right, hell yeah. So we have 9, 9, and then negative 1 times negative 1 is positive 1. Positive 1. So 1 times 9 times 9 is 81. All right, so how and what are we going to do here? Well, this is a little bit different. This was negative 1 times 3, and this was equal to negative 3 in parentheses, and we took that to the fourth. See how these two are the same? This is going to be a little bit different, but we can treat this negative sign as a negative 1, and then we're going to have 3 to the fourth. So this exponent of 4 is only on this 3. So if we wrote this as a product, it would be negative 1 to the 1 times 3 to the fourth, where this was negative 1 to the fourth, 3 to the fourth. So that's the big difference here. And so hell yeah, negative 1, we're just going to have one of those, and then we're going to have 3, 3, 3, 3. Alright, so hell yeah, so I already think this video is just really good, because I just feel like no one's going to go over like that, you know, like detail, I guess. You know, just because it's a little bit, you know, you have to write out a lot of different things, but it really spells it out. So this is 9 times 9, negative 1. Hell yeah, it's going to be negative 81. Even if you're in chemistry writing out what is that number? 6.02? I have no idea. 6.02? 6.2 times 10 to the negative 23? I mean, just how hard is it to write 6 and then 23 zeros? Let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Hell yeah. It's not that hard. You know what I mean? Is that a mole? You're just going to have that number. You know what I mean? Point oh, or whatever. But hell yeah, it's not that hard to write out even very large numbers. And why I just did that is because, hey, sometimes you don't want to just, hey, if you had negative 3, if this was to the 12th, well, hell yeah, just do it 12 times. It kind of helps you visualize a problem. All right, now this is going to be 3 to the negative 4. Oh yeah, okay, yeah, so, and then I want to try to learn tricks, because I just know that this is just 1 divided by 3 to the 4. I know that 3 to the negative 4 is just 1 divided by 3 to the 4. But there should be like a basic unit, what am I saying? I'm saying that this should be the same as, oh yeah, let's do that same thing. So we're going to have, this can be 3 to the negative 1 times 4. Okay, hell yeah. I gotta pause the video. I wanna do something here. I just don't know where I'm going with it. Holy hell! I'm glad I paused the video. I can make a tutorial on this that I just don't know it. But yeah. So anyway, so it's 3 to the negative 1 to the 4. I was just like, well, I had to do like a whole series here of like, well, let's not get into it. But this is equivalent of saying, hey, let's do 3 to the 4 first. So we're going to do 3 to the 4, but then we're going to take this to the negative 1. So after we do that, and that's what I had to confirm that. And so this, actually, let's do this, because this brings up a topic. What I did to confirm this was I took 2 to the 2 times 4. I just wanted to do this, you know, and then just make sure it was going to be the same as, you know, can I take 2 squared as 4, and then can I take 4 to the 4th, and that's going to be 4 times 4, 4 times 4, this is 16 times 16, that's 64. So the answer here is 64, and that would be the same as taking 2 to the 4th, and then 2 to the 4th is 2 times 2, 2 times 2 is 4 times 4 is 16, and then 16 squared is going to be 64. So yes, so these is the same as 2 squared to the 4th, which is the same thing as 2 to the 4th squared. So yeah, that's so interesting. So now that's going to be very useful, because what we can do is we can do 3 to the 4th and say, And then, so we can do this. We can say, hey, this is just 3 to the 4th, and then we can take it to the negative 1. And taking something to the negative 1 is turning it into an inverse. But 3 to the 4th, we're going to have 3 times 3, 3 times 3. This is going to be 9 times 9. So we're going to have 81, but we're going to take it to the negative 1 power, which turns it into 1 divided by 81. And the other way to do it was what I wanted to do right off the bat, was just saying, hey, this is just 1 divided by 3 to the 4th. You know what I mean? Which operationally is I did to the negative 1 first. So yeah, so I definitely like my strategy of saying this is 3 to the negative 1. So turning this negative 4 into a product of negative 1 and 4. And then I can take 3 to the negative 1, which is 1 third. Yeah, 3 to the negative 1 is 1/3, and we're going to take that to the 4th. And then so even here, hell yeah, you have that property of like, if you have an exponent of a fraction, well, we're gonna take 1 to the 4th, and then 3 to the 4th. Just because you have division here, this is the same thing as 1, 3 to the negative 1. You know what I mean? I'm sorry, 1, 3 to the negative 1. And which is exactly what we have right here. It's just 3 to the negative 1, and you could add another 1 out here to make this make sense. Sweet. So yeah. So, and then if we took this to the 4th, we would have 1 to the 4th, which obviously is just 1, and then we would have 3 to the negative 1 to the 4th. And so, yeah, I definitely wasn't too clear on that. But yeah, it's just fascinating, like, being able to do things in a bunch of different ways, just so you're not stuck in doing something one way. I'm gonna get some more paper. All right, hell yeah! But let's redo this one again. So we have 3 to the negative 1 to the 4th. I'm gonna do this as 3 to the negative 1 to the 4th, which is 1/3 to the 4th, which is 1 to the 4th, 3 to the 4th, which is basically just 1, 3 to the 4th. So that's just a long way to just do what we already know how to do in our heads, maybe. If we see 3 to the negative 4, it's just 1 divided by 3/4. But, I mean, what I like to do is like pretend like you're not going to do math and physics for the next 10 years, and you're going to have to come back to this. And then what? You know what I mean? So it's good when you are studying, be like, is there multiple ways? I think having about 3, 4, 6, different ways to get places will help you when you forget it all. All right. So, booyah. And then 3 to the 4, that's going to be 9 times 9. 1 divided by 81, that's what we have here. Alright, so sweet. This, I don't know. I just know to subtract, but even just saying that is just like, oh, well, I can come up with another way. You know what I mean? And, exactly what we just did here. Like, this is perfectly synonymous, like analogous. We just wrote out 23 zeros. All you have to do right here is write out 23 fives. But let's just say this is 5 to the 3rd divided by 5 to the 1. I'm going to have 5, 5, 5, and then downstairs I'm going to have 5. Hey, those cancel, and what am I going to have upstairs? 2 5s, 5 squared. And then you could, so this is also a good strategy. Well, let's say I had 5 to the 13, and then 5 to the 11. You know what I mean? It would be 13 upstairs, 11 downstairs. It's very synonymous with 23 and 11. So, blah, 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 I would have 13 of those. I would have 11 of them. I would have probably 2 extra upstairs, and hell yeah, we'd have 5 squared. And so I'm definitely not going to write out 23 fives, but we should. Let's do it. It's not that hard. You know what I mean? I need to practice what I preach. So let's count them out. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, that's 20. And then 1, 2, 3. Sweet. And then we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And hell yeah. And we'll work on that later. 1, 2, 3, 4, 5. So that's 15. 1, 2, 3, 4, 5. That's 20. and 21. So hell yeah. So let's start. So we have this, and you know, we're multiplying 5 23 times, and then downstairs 5 21 times. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then, so that's 20, 21. So the 21 5s downstairs cancel 21 of the 23 5s upstairs, and we're left with 5 squared. 5 times 5. Hell yeah. But I don't know. I find this satisfying when you allow yourself to do something that you know is going to take about a couple minutes. Because if you don't, then you're going to reach like huge blocks while tackling harder problems. If you're not even willing to go, like let's say this was a dead end, but I was just curious. Like I probably knew it was going to get me the wrong answer, but if you're not willing to go to like write algebraic expressions for more than 5 minutes, then that can be a detriment to problem solving. Alright, booyah. Alright, so hell yeah, let's use all these skills to fly out these last two, because I think they're kind of difficult. Alright, so we're going to use that strategy that if you have an exponent here, this is the same thing as 2 to the negative 2 divided by 3 to the negative 2. Okay, and then we can do that same game. I can say this is 2 to the negative 1 times 2. And this is 3 to the negative 1 times 2. And I think this is helpful. Because seeing a negative 2, I don't know. Like it spells inverse, but only the negative 1 kind of spells inverse. The 2 spells square. So you have to inverse. That's why it's the inverse squared. So, and since we have kind of two fractions here, you know what I mean? Should we just do this? Well, hell yeah. This now becomes, well, we can say that this becomes 1/2, and we can still have our fraction sign. So that's what that happened. And then now we're squaring this, so we still have that. This becomes 1/3, and then we're squaring this. So even doing it this way, no one's going to do it that way. You know what I mean? You're just going to be like, hell yeah, 2 downstairs, and we're going to square it, 3 upstairs, and we're going to square it. So, and then we're going to have 9 divided by 4. So definitely just saying, oh, we're just going to invert that. We're going to have 3 halves and then square it. That's going to be 9/4. Get on with life. You know what I mean? But then it's just kind of fascinating going through this technical process. So we could even continue doing this. We could say this is 1 squared divided by 2 squared. And then we have 1 squared divided by 3 squared. So now we have 1 divided by 4 as a fraction upstairs. Then we have 1 divided by 9 as a fraction downstairs. Dividing by a fraction is the same thing as multiplying. So we're going to multiply by the inverse of this. 1's cancel, and we got 9/4. So hell yeah. All right, last one. All right, booyah. So we have 16, and see like right here. This is going to be very classic for being like, hey, let's say this is -1 times 3/4. And then even here, like what is this? This is going to be 16 -1 times 3 times 1/4. All right, hell yeah. And then so I think it's good to be like, what does a fraction do? You know what I mean? I even kind of forget. But you know what I mean? Like let's say what's 4 to the 1/2 power? Yeah, I don't know why this is 4, just 4 square root 4. So square root 4 is synonymous with 4 to the half. Yeah, why? So why is that? Like, let's say you had 2 squared. That's going to be 2 times 2 is equal to this number. So then the reverse, taking this number to the 1/2, is saying what 2 numbers, so I'm going to make triangles, what 2 numbers squared, what 2 numbers when you multiply them together equal the number that we're trying to take the square root of. You know what I mean? Because if I had 2 times 2, and this was going to, so 2 times 2 is 4. So now what's the square root of 4? That means that, hey, 2 numbers, when multiplied, have to equal 4. What are those numbers? And so, you know, it's going to be 2 times 2. And that's the definition of 4 to the, so 4 to the 1/2 power. Yeah. And I still don't know why. You know what I mean? 4 to the 1/2. Yeah, that's a big, I could not teach a course on 1/2 or like powers, exponents of fractions. Like 1 to the 10th is the 10th root. Well, yeah, 1 to the 10th. I guess it just means, so if I had 1 to the 10th, it means that, hey, 10 numbers added together. If I had root 10 of 100, it would be 10 numbers added together equal 100. You know what I mean? And let's say I had to even just guess what that would be. If I had 2 times 2, if I had 2 to the 10, well, like that's probably going to give me more than 100, right? Because 2 to the 10, I should know 2 to the 10. I think it's like 10,000, right? No, I think 2 to the 10 is, what is 2 to the 10? Well, we can do it. 2 squared is 4. 4 times 4 is 2 to the 4th. That's going to be 16. 2 to the 8 is 64. Wait, is that right? And then times 2 is just 120. Yeah, 2 to the 10 ain't much. What was I thinking? Yeah, holy Toledo. So we have 2, 4, 8, 16, 32, 64. Wait. That's just 2 to the 6. So yeah, we got off here. 2 squared is 4. So, and then, so 2 to the 4 is 16. Yeah, that's where I got off. 16 times 16 is not 64. Hell no. 4 times 16 is 64. Yeah, I think 2 to the 10 is 10,000. What is it? Is it 1,000? I think 2 to the 10 is 1,000. So, yeah, I don't want to go through that. Well, I mean, we could, but we're not. Yeah, 2 to the 10 is approximately 1,000. But yeah, so what do we get? We got 2 to the 4 is 16, so 2 to the 5 is 32, so 2 to the 6 is 64, and then 2 to the 7 is 128. 2 to the 8 is double this. That's going to be about 250. But we have 256, and then that's 2 to the 8. 2 to the 9 is basically double is about 500, but 512, and then 2 to the 10 is 1,024. So yeah, this is good for reducing numbers. If you have any number that's 2 to like the 105, you can be like, well, this is basically 2 to the 10 times wait, divide this by 10? Yeah, what's that? 10.5? Yeah, so we would have, no, we're right. Yeah, so if I have a big number like 2 to the 10, well, that's going to be 2 to the 10, like 10 times. So I'm going to have 1,000, which is 10 to the 3. 10 times. So I'm going to have 10 to the 30. So yeah, just taking a big number like 2 to the 105, which is like if you doubled, if you had $1 and then you doubled it for 105 days, how much money would you have? You'd have 10 to the $30. You know what I mean? Which is easier to figure out, which is easier number to visualize than 2 to the 105. That's hard to visualize. Cool. All right, so what do we do with that knowledge? I have no idea, but I need to go back and figure out why, if you have a fraction, like why this 1/4 is the 4th root of 16. I'm not going to get it in this video, so I would definitely just have to watch a tutorial. But what I guess what I do know is that, so back to this one, we have 16 to the -1, to the 3, to the 1/4 power. So we're going to do this 1/4 power first. And so we're basically saying what times what times what times what. 4 things have to add up to 16. So let's just try. 1 times 1 times 1 times 1 is 16. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So there it is. So it's just 2. So cool. So these two things are now just 2. So now we have 2 to the negative 1 to the 3. 2 ways to do this. We could say, hey, 2 to the negative 1 is just 1/2 to the 3rd power. And that's going to be 1 to the 3rd, 2 to the 3rd, 1 divided by 2 to the 3rd is 2 times 2 times 2, which is 4 times 2, which is 8. So we have 1/8. Or you could do it the other way. You could say 2 to the 3rd is going to be 2 times 2 times 2, which is 8. And then we have to the negative 1, which is just inverting it. So we have 1/8. So hell yeah. So this answer is 1/8. All right, that was brutal. I'm actually going to go look online of like why. I mean, is it just because they say so? Or like what's the mathematical rigor behind an exponent? Because this is what happens in math is just like, yeah, you have an expression. Like let's say you have 1 plus 1. I mean, it just says, hey, you got to take this, and then you have to take something similar to it, and then, combine them together, and now that's what you're doing. So I feel that this fraction doesn't mean anything, from an operational standpoint. Like just as 2 squared, when you do this, I mean, there's nothing in your calculator that says, oh yeah, I know what to do now. Like you have to program that in. You have to say that, hey, this, just even an exponent as an integer just means that, hey, we're going to take this number and then we're going to multiply it. And even what the hell does multiply mean anymore? Like I don't even know now. I have 2, and then we're going to, I guess we're not adding 2 and 2, but even though 2 squared is the same thing as 2 plus 2. Hell yeah. So I'm going to have 2, and then we're going to, what's the difference between 2 plus 3? You know what I mean? Well, I would have these 3 blocks, and I would add them together. I'd have 5 blocks. You know what I mean? So I'd have 3 blocks and 2 blocks, but 2 times 3 means that I have these 2 blocks, but we're going to have, 3 piles of them. And so that is substantially different than just adding those 2 numbers. Okay, hell yeah. So if I have 2 squared, that means I'm going to have 2, and then I'm going to have 2 piles of those. If I have 2 to the 3rd, that means that I'm going to have 2 times 2 piles of 2. And then I'm going to have this, and I'm going to have 2 piles of... No, that's not right, is it? Yeah, no, that is right. I'm going to have this. Now, this is my new quantity. So 2 to the 3rd is 2 squared, and then squared again. You know what I mean? So I'm taking 2, and then I'm going to make 2 piles of 2. That's 2 times 2. 2 times 2 is this. But then if I'm going to square that, 2 times 2 squared, hell yeah. Then I'm going to say, hey, now I have these 2 things together, and I need to make 2 piles. Well, no, I have to make, holy Toledo. No, I guess I just need to make, 2 piles of these. So I have 1 pile there and 1 pile there. Yep. That's not, yeah, I didn't square this number. I said 2 squared. Holy hell. So 2 cubed is the same thing as 2 times 2 times 2, which is 2 squared, but just times 2. So yeah, I'm having 2, and then I'm going to multiply it by 2. So this in 2 piles. And then once I have this, I'm just going to take this and then double it. I'm going to have 2 piles of these. Hell yeah. I'm not going to square this. If it was 2 to the 4th, yeah, then I would have, let's do that one and be done with this video. But I really enjoy this because that's the whole idea of doing, you know, like diagnostic tests. Because it can expose your weaknesses, and if you don't play around with your weaknesses, I don't know, like you're just, down the line, if you do that with everything, you're going to get to places where you're just going to make up stuff. And then lose the fundamental understanding of what's going on. Alright, so we have 2 to the 4th. So I could say this is 2 squared times 2 squared. So 2 squared is 2 times 2. So that's what we're looking at first, which is 2, and then 2 piles of that. Sweet. So now I can have this. And if now I'm squaring that. If I'm squaring this, I'm going to have this, and this is 1, 2, 3, 4, and I'm going to have 4 piles. So this squared is 4, but we're going to have 4 piles of that. Alright, hell yeah. So, and there you go. So this would be 2 squared, which is 4. And if I squared this, I would have to have, since there's 4 here, I would have to have 4 piles of those. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that'd be 16. So 2 to the 4th is 2 times 2 times 2 times 2. Which, how do we do this? You would have 2, and then you'd have 2 piles of that. So, booyah. And then you would have that, and you would have 2 piles of this. Okay. And then you would have this, and then you would have 2 piles of that. Okay, yeah. So that is, that is pretty interesting. And I think what we did here was fascinating too, because we said we're going to have 2 piles of 2. Hell yeah, that's 2 piles of 2. And we're going to multiply it by 2 piles of 2, which is same this squared, which is, I have 4 here, so I need 4 of these. 4 piles of whatever I have here. And that's going to be 16. So hopefully I'm saying that halfway right. But yes, I do need to look up on the internet why the exponent of a half symbolizes the square root. Symbolizes like what times what. If it's 1/2, you got to do this twice. What times what is equal to that number that you're halving. So if this is the number I'm trying to go to the 1/2 power, the output isn't these 2 numbers, just one of those. So it's just that. Even though I come off to the side and it's like what times what equals this square. So what times what equals the thing in the square, but the output of this to the 1/2 is just one of those numbers. So hell yeah. And yeah, I'm very fascinated to go online right now, so let me do that. And if I don't come back, hell yeah, this was a pretty decent one. Not really. But yeah, it's fun to show where the struggles are, even for me. And if I didn't watch like some videos on this type of thing this year, like there was, I can't find the gentleman that just really, every problem really goes into exactly what I just did there, like all the time. Because if you don't do that, then you're going to kind of forget those rules. And I really enjoy like having 3 different ways to get there, so I think we did it. Alright, so hell yeah, thanks for joining me. That's a video.